Welcome to MyProjectBazaar. Our project title is Active Learning of Constraints for Semi-Supervising Clustering. The aim of the semi-supervising clustering algorithm is to improving the clustering performance by considering the user supervision based on the pairwise constraints. In this paper, we examine the active learning challenges to choosing the pairwise must-link and cannot-link constraints for semi-supervising clustering. The proposed active learning approaches increasing the neighborhooding based on the selecting the informative points and querying the relationship among the neighborhoods. And we enhance this process instead of a clustering process, we using the classifications process. It is one of the such a most popular approaches which involving the use of local classifier that embedded the nodes, zones, attributes and the neighboring information in the feature vectors and classify the nodes in the iterative procedure. In data, the nodes can be represented using the multiple types of attributes and there are multiple link type between the nodes. The proposed method involving the benchmarks datasets and the results show that the proposed system yielding the better output over the current state of art. In data flow diagram, first of all we choosing the dataset for the process. Here we using the movie lens dataset. In the dataset, first we applying the pre-processing technique. In the pre-processing technique, we removing the unwanted data from the dataset that are present while the database is generating, and we eliminating those unwanted data from the dataset, and we uploaded this dataset in a database. After that, we splitting the data into multiple tables, and when we comparing the each table with one another, and we finally we filter out the result depending upon their what are the relationship found between those tables, and we classify those tables, and finally we applying the clustering or classifications in the process. For enhancement work, we apply instead of clustering, we applying the classification. Now we are going to start our demo. Our project title is Active Learning of Constraints for Semi-Supervising Clustering. Just clicking that button. Then here we are going to uploading our data. In that choosing the dataset folder. In that choosing separate user. Then clicking the user data. This dataset containing the user ID and their movie ID. User ID, item ID. Item is the movie ID and the rating given by the user and the timestamp. The timestamp is the time for the movie, on which time the user will see those movies. Okay, these are all the information. And then click the data loading. Here we are going to choose in the item.txt. In this data, it containing the information for movie ID, movie name, movie releasing date, and the link for that particular movie. And then these are all the category the movie presented. In this, there are under 3 category the movie released, and in another it containing it also containing in 3 category. Then clicking next. Then creating a table. Then updating those informations in the databases. And databases updated. Okay. Then applying the pre-processing technique to remove the unwanted data from the database. Okay. In this containing movie ID, movie name, and the movie releasing date. A note is representing movie ID, the A1 representing movie title and the releasing data, and the ID URL, and then these are all the generic the movie released. Unknown, action, adventure, animation, children. These are all the categories of movies. Then click next. and here we are going to find out in the distance informations. For example, here we choosing any one user. For example, we choosing 200 user ID. This user ID, the 200, the user 200 are watching these movies. The individual user watching 222, 673, 318. These are all their movies seen by the user ID 200, and their ratings given by the ID given by the user ID and their timing. Okay. After that, just clicking that any one movie ID. For example, we are clicking 11 means here it's showing the movie ID 11 and their informations. Movie name, what are all the data in the database. That's viewed in here. And then just click the ID. These movies are viewed by those users. Actually, initially we find out the individual users. What are the movies are watched by the individual user, and we find out in the individual movie, and while clicking that individual movie, how many of them are viewing that individual movie. Likewise, we find out in the relationships. Then click next button. Okay. Here we are going to find out in the number of generic for the particular movie. The number ID 2, 3, these are all the IDs, and this is a movie name, URL path, and this is a generic. The number 2 movie containing is released in 3 generic and 3 released in 1, 4, 3. And we're going to find out the prediction value for each movie. For movie 2, the prediction values we find out in the each movie. Here we're going to find out the any two preferable generic. We find out in the similarity values. From that we calculating the average weight and find out the nearest neighboring for 119. Likewise we find out in the nearest neighboring values. And then we find out in the relationship with movies, individual user relationship. User ID viewing total overall 272 movies, and the ID 2 viewing to overall 62 overall. So these are the overall count of the movies viewed by the individual user, and the number of users in the process is 1 lakh. After that we find out in the movie relationship with user, that particular movie is viewed by how many users. Number 2 is viewed by the 131 users, and the 3 is viewed by 90 users. Each movie is released under different categories. Here we choosing 1 means these are the 1 which are presented in under 1 category, and for 2 it presented in 2 category, and the topmost is 6. Okay, next, and the number of movies seen, top movies, these are all the top movies seen by user. By calculating the number of count the movie is viewing, 583 users are viewing the 50th movie. Next we are going to find out the movie generic already seen. and finally we classify those. Thank you.